Okay, so the topic is LabVIEW, and LabVIEW is produced by a company called National Instruments. They're based in Austin, Texas. They're $1 billion company, and the product itself is ubiquitous in the technical field of data collection and scientific measurement and test equipment. And so LabVIEW is the background network communication link that that an engineer will talk to his equipment when he's doing tests on a new process or a new product. So primarily what you're going to see is we're going to be building programs that are the suffix is .iv or VI, and that's because it's a virtual instrument evolved or a legacy holdover from the days in data collection. LabVIEW is actually a graphical user language, not a programming language, which allows us to connect icons on the screen. And as we do that, it generates code in the background. So there's actually, and it's called G code, there's actually a way, if you were to get into it, that you could actually go in and modify the G code, none of which we're going to be dabbling in when we get into the depth of this. What we use, FRC LabVIEW, is a customized version of the standard product. If you were to buy this group of modules that we've installed on our computers as an individual engineer, it would run anywhere from $15,000 to $25,000. And consequently, you have a license to this tool for a year. And my recommendation is learn to drive it like it were a sports car that you don't have to worry about getting dents in it. So I have a bachelor's in electrical engineering and computer science, and I've been a mentor for FRC LabVIEW for 11 seasons now. I actually have no formal training, so I'm self-taught, but I refer to myself as a LabVIEW expert, and for a good reason. If you know who Niels Bohr is, he's the guy that came up with the atom model, or the model for the atom that we use in most fields. And he defined an expert as a person who has made all the mistakes which can be made in a narrow field. And that pretty much describes my experience with LabVIEW. I have made a ton of mistakes, and the reason for emphasizing that is that that's how you're going to learn it, is don't be afraid of making a mistake. And the more mistakes you make, the better off you're going to be, the more you will know the topic. So the way I have this set up, the first 3 classes, we're going to be focused on the LabVIEW mechanics, the use of the mouse. I want to encourage everybody to use a mouse, not a touchpad, because there's a lot of versatility, and it's just more difficult accessing all the different features that are in LabVIEW without a mouse. We're going to be watching, utilizing the help system, utilizing examples. And again, stop me if you don't understand what I'm doing, or if you get lost on your end of it. Let's stop there and back up until we get everybody on track, because it doesn't do any of us any good if you're lost at the end of a session. Now, the difference between watching a video of me doing this stuff and having this live conversation is the ability to ask questions and let me see your code, because by that exchange, I can tell what I didn't explain correctly. And there's about 26 different ways to explain this stuff. And if I start off one that doesn't make sense to you, just let me know and we'll back up and try another approach. Now, the first 2 or 3 classes, we're going to be using the blank IV, which is not really used in the robotics area, but it allows us to simulate the robotics elements. So that's what it's all about. And then we'll actually get into the simulator and start learning the robot project configuration and then specific sensors and actuators. And then probably about the 6th or 7th class, we'll actually have access to a physical robot. And so we'll start getting into more detail about how to actually, let me back up and make a point. As the programming team, one of the things you want to have access to once you get some of these skills under your belt is to either have access to a prototype board which has the basic system elements on it that you can practice programming, or an old robot. And so you would, as a programmer, you want a request of your wiring team to put together a prototype board, and we'll get into what that entails, the different pieces you want to include in it. So don't be afraid to kind of make that a priority on your side of the aisle. Okay, here's a pop quiz. What's a programmer's most important responsibility? And I'm open to people making guesses at this. Designing the robot operation guide, robot safety, accurate bug-free code, game strategy, testing the code before drivers use the robot. Anybody want to hazard a guess? What's the programmer's most important responsibility?
Safety.
Bingo. And I can't overemphasize that the robot only does what the programmer tells it to do. And so if we don't keep safety on the front of our mind as we're developing the code, there's no chance that the system will operate safely. There's a good chance of, and again, that goes into the point about the error, making mistakes, is you want to make a mistake in the prototype stage or the simulation stage where you're just in the confines of the computer and you're not in the physical world of the robot itself. So as we start to, you'll see me kind of come back to that mentality that there are ways to kind of ease into an area when you haven't done that particular feature before, like move the robot itself. You want to make sure you start slow before you start turning the throttle up high. So anyway, there's a bunch that's related to a bunch of different sensors and actuators when we actually get to the robot. So who was that answered that right off the bat?
Me.
Who's me? I'm not looking at the.
Andy.
Okay, thank you. I appreciate you jumping in there. Okay, the next thing I want to emphasize is the word simulate. And as I do that, I'm going to jump out of this presentation and go to the next one. If you Google simulate, the definition comes up with that you're going to basically imitate either the operation or the look and characteristics of something else. And so one of the things I'd like to encourage everybody to do is to try to use as much as possible the correct terms. And sometimes if it's not familiar to you, it's a challenge. But the better we communicate and the better we utilize the correct terms in that communications, the more efficient the team environment will be. So don't be afraid to use these terms, whether you feel that you fully understand it or not. Again, that's another way to make mistakes that you can learn from. So simulation is making something look and feel like something else, and we're going to do that here in about 5 minutes. There are numeric signals, which some people call analog, that relate to the real world numbers. And again, in data collection and measurement, that's an important aspect of the engagement with the environment. There's Boolean signals, which are digital signals consisting of ones and zeros. There's a subset of numeric or analog signals that are referred to as integers, and that's the whole value of the number itself. You're going to see a driver station is the next thing we're going to jump into, and that's the communication link between the program and the physical robot itself. Now, we're going to be doing a lot of work, at least in these first couple, 3 classes, using what I referred to as the blank VI. It won't be something we use on the robot, but we will use it to simulate different parts of the robot. And part of that is the LabVIEW controls and the LabVIEW indicators that we're going to be seeing on the front panel. And again, what we're doing is simulating different systems in the robot itself. Then we're going to be talking about while loops, context help, loop time or repeat time, bandwidth, and then human interface devices, all of which have a part in the world of robots. So again, the definition of simulate is to make something appear to have the look or character of something else. So the first task we're going to do is simulate a joystick and a robot motor using a slide control and a numeric meter. And to do that, I want to use the driver station to investigate what or how the output of a joystick looks to the driver station. Anybody want to comment on that? Or so at this point, I'm going to open the driver station, and it looks like, for those of you that haven't seen the driver station, it looks like this. All right, so here's where watch how I do this. I'm going to go down to my Windows. Now, Paige, this is what I was trying to get you to do yesterday. If you go down to your Windows Start icon, you get the list of your applications that are installed in my computer. And if you properly installed the FRC game tools, you'll get an icon on this list that says FRC driver station. And in some cases, you actually get it attached to your start menu. So I'm going to click on this icon. It's going to say, hey, there's something that's going to be controlling your computer from somebody else's program other than Microsoft. And it's going to show me with some little audio clues the driver stations. So those of you that have got it installed, go ahead and see if you can find and launch the driver station. And I'm going to talk about it while you do this. It also launched the second window, which is the dashboard, and there was another security access release that I have to say, yep, it's okay to run this application as well. So anybody not able to launch the driver station and dashboard?
Mine. Oh, sorry.
Well, go ahead.
My software has taken a while to install, and I don't have it installed yet.
Okay. Well, so we'll look at that at the tail end. So like I say, just watch what I'm doing, because you want to be able to do this once you get the installation complete. This is something you're going to do dozens and dozens of times, and that is launch the driver station. So just sit back and watch, and feel free to ask questions as we're going through this. Anybody else have trouble launching the driver station? Does everybody get it going? And don't be shy. Give me a yes or no.
Yes, sir.
Thank you. Anybody else?
Okay, here.
Okay, good.
Got it launched.
I've got it.
Yes.
All right. Anybody not got it? Okay, so here's the deal. I'm just going to walk through some parts of this. And for those of you that have a joystick, now's the time to plug it in. And those of you that don't, just hang in there with me, because we're going to cover that first thing next week, is to simulate a joystick. But here's what I'm looking at. In the dashboard, this shows my joysticks, and there's a left and right. And as I move the in fact, you can see from the indication on the driver station that it's identified a joystick that I have plugged somewhere in my system. If I move the left joystick up or forward, I see the indication on the display on the dashboard that it goes forward. If I move it back, it goes backwards. Now, if I move it left and right, it does that, and I can move it part way left or up and left, and I can position the dot anywhere on the screen. Well, it turns out there's two signals that come out of the joystick, and we're going to get back to that in a second. Right now on the dashboard, on the driver station, I'm looking at the operations icon on the top left corner of the driver station itself. The next button down, and we'll come back to is the diagnostics. And once we get to a physical robot, this will tell us how well we're communicating and what links we're using to communicate it with. The next icon is the settings icon. You need to put, if you haven't used a driver station before, you need to put your team number in this slot where it says team number. And that's an important part of the setup. Now, dashboard type, it says default. And that's what we're looking at up here. If I pull down this arrow and say LabVIEW, the dashboard disappears. And that's due to the fact that we haven't created a LabVIEW dashboard yet. I can go back to the default and it'll reappear, the dashboard will reappear because of that change. Everybody following this? Is this all working for you? All right. Now the thing I want to do, and I'm guessing not everybody has a joystick, so you need to kind of watch what I'm going to be doing here. The next icon on the left is the USB section, and these are all the different ports, and at one point or another I've used these different joysticks, but the one that's active is my slot 0, and it's a controller for the Xbox. And as I move the joystick, you can see that those two signals change. One is for the X-axis, the top one, and one is for the Y-axis. And so what this nomenclature is that the first output is an analog output from my left joystick. It's a 0, it's returned to 0 value. So when I let go of the joystick, it goes to 0. And if I move all the way forward, you can see the signal on the left axis goes negative or goes below 0. Everybody see that? When I push the joystick forward, my analog signal down here on the driver station goes below 0. And just because I've done this before, the maximum value I get when I push the joystick all the way up is a -1 out of the joystick. If I pull it all the way back on the Y-axis, I get a +1. Do you see what I'm referring to? Paige, does this make sense?
It makes sense to me.
Good enough.
I'm not seeing where the number is. You say you're getting a 1 or a -1. Where are you looking?
It's not indicated here. I'm looking at it from doing programming for 11 years. So
Okay,
I'm just saying it's
so there's
relative.
no numbers.
Correct. Now, that's a good point. I'm going to jump to the side here. If I go up to my basic display on the dashboard, there are numbers for the slide switches here, and we'll be using these in class 4, I think. And they go from 0 to 5, which is not a good number for a robot. That's in a digital format, so we're going to deal with that. So keep that in mind. You're exactly right. So it's just from having done this a lot, the maximum signal I go in a forward direction is a -1. The maximum signal I go To the left is a -1 on the x-axis. If I go all the way to the right, I get a +1. If I go all the way backwards, I get a +1. Okay, so that's the characteristics of my joystick. Now, and you're right, it's all relative. I just know it's negative and it's positive because it's a return to 0 signal. I'm just telling you that 1 is the maximum value we're going to see. Okay, Jim, what do I do with this? Now we open up LabVIEW. LabVIEW, I'm going to go to my Windows Start screen. And LabVIEW icon is this little triangle with NI LabVIEW 2019. When I click on it, it opens LabVIEW. There's 2019. And if I've got it properly installed, it comes in with the FRC update and dates it 2021. Now, we're going to go all through this in future classes. Right now, I'm just going to click on the blank VI and talk about what I'm seeing right here. I've got 2 windows come up. This one in the front, it's got a gray grid pattern on it. This is referred to as the front panel. If I click on the one behind it, which is all solid, kind of off-white, this is called the block diagram, and this is where the programming's done. Back on the front panel, this is where the controls and the indicators are used. Now, here's where I need you to stay with me or to do what I'm going to do. I'm on the front panel. I'm moving the cursor around this little crosshairs. I'm going to right-click the button on the mouse and pin the controls push pin here at the top to lock the screen in and not hide itself. Now, all these things that we're looking at are called palettes. We're going to change the look so everybody's looks like mine. I want to click on Customize, change visible palettes, deselect all, then click on Modern and click OK. And I get a reduced size of my palette. Everybody follow that? Okay, stop me if I, thank you. Anybody not get it? All right, the way I close this is if you click on the palette itself, it shows me where there's a red X. So once I click on it, it takes the palette away. All right, what I want to do is right click again now, and I see my reduced palette. I'm going to go to the numeric palette, and I'm going to left click on vertical pointer slide. And as I do, it gives me the outline of the slide, and I'm going to put it in the center of my screen, click a second time, and it's got the name highlighted. I'm going to type in joystick. So there's no spelling, there's no penalty for misspelling, but I want to type in joystick. And then I click off of it. I position the cursor off of the name and click again to deselect it. All right, now I want this joystick to match the signal that we get out of the driver station. So when I'm all the way forward, instead of 10, I want to double click on 10 and make this a -1. And then deselect it. I want to come down to 0 and double click on it and make it a +1 and deselect it. And my joystick should look like this. Anybody not able to do that? All right. Now I'm going to go back to my palette, my numeric palette, and I want to pick up the meter down here on about the 3rd or 4th row. Click it once, position it somewhere near the center on the right side, click a second time, and it's highlighted the word meter. I want to type in motor. So a motor, you can tell spelling doesn't count if you're watching me. Okay, the motor is a linear output device. Again, I'm going to double click on the 10 and make this a -1. We're going full speed forward. We're giving the motor a -1 signal. And then double click on the 0 and make it a +1. Now, good programmers annotate their code, and in EasyPower, in LabVIEW, that means we have notations. So I'm going to position the cursor here about 2 rows below the meter, double click, and it shows me I'm starting to type in there. I'm going to say forward, type forward, and then click off of it, and then double click near the left-hand side of the motor and type in reverse. Again, what we're going to do is we're going to simulate the joystick driving a motor. And we want, when we push the joystick forward, for the motor to go forward, and when we pull the joystick back, the motor to go reverse. Everybody got something close to this on your front panel? Anybody not have it? Okay, now we're going to click on the block diagram. You can see we have 2 elements here. I'm going to left click and drag until I've selected the joystick and position it about 1 inch away from the motor, just to make it look neat. As I move the cursor around the screen, you can see the cursor changes shape, and the motor change, and the icon for the motor changes shape. First of all, it's got an orange outline. That means it's a numeric control. And as I hover over the middle of the joystick, it shows a little nipple here on the right. That's a connection point. And if I hover over that connection point, I get a spool of wire. That's the icon. If I go to the motor, I see it's an orange outline, which means it's a numeric indicator. It's got its nipple on the left-hand side, which means, again, it's an indicator or a load. And when I hover over it, I get the spool of wire. I want to hover over the joystick nipple, left click with the spool of wire, connect it to the motor's nipple, and click a second time. All right, now I'm going to go back to the front panel. With the white finger, with the white fist, if I hover over the slide, it gives me a white hand. I can left click and change the value that's indicated on the joystick. At the very top of the front panel is a white arrow on the left-hand side. If I click that white arrow, the value on the motor changes to the value that I've set on the joystick. If I use the white finger to change the value on the joystick and I click the run button again, it changes the value on the meter, on the motor itself. Everybody see that? So what's happening? Let's go back to our, was there a question?
No, I was just saying yes to your question.
Andy, I like it. I appreciate the feedback. Okay, I'm back on the block diagram. What's happening? And I was thinking about this today. From this point on, you really need to think in terms of word problems, because that's what a robot project is being able to state a word problem that you're going to solve. And in this case, what we've solved, the effect, we've written a program that connects the output from our joystick to the motor when we run the program. Now, having it happen once isn't going to do us much good. So now we need to incorporate this in a repeating program. Position my crosshairs in an open area and right click, and I get my function palette. I'm going to use the push pin at the top to peg it, and then click on customize. And we're going to change visible palettes here so it'll look, they all look similar. We're going to deselect all, click on programming at the top, Scroll down to the bottom, click on WPI Robotics, Library, PID, and First Vision, and then click OK. Now again, just like before, to close this, you come up and there's a little red X that shows up. All right. Right-click again in Open Area, go to the Structures palette, click on the while loop, which is top row center. Position the cursor up and to the left of the joystick, left-click and drag until you get a rectangle about that big, and let go. Anybody lost or anybody have a foul? There's nothing wrong with,
So
go ahead.
what boxes did you check? Because mine isn't looking the same.
Okay. Whenever I right-click on just an open area, I click on the push pin, and then I customize to change visible palettes. Deselect all, click on Programming, scroll down, click on First Vision, PID, and WPI Robotics, and then click OK. Now I'm going to close this, and when you come back and right-click, it should look like mine. Did you get it?
We have a question.
Okay.
Yeah, it works now.
In our palette, it doesn't display the text labels underneath the various icons, so it's hard to tell what's what. How do we get that?
You pin the palette like we did before with the push pin. Come back to Customize. View this palette as category and text, or icons and text.
Thank you.
Thank you for asking the question.
And
Okay.
this big box you just drew, that was a while loop?
Yep. And thank you for getting me back on track. So this is a while loop. Everybody got the while loop made? Anybody not have it at this point? Go up, put your cursor on the help word at the top menu bar, left click, and select Show Context Help. And it puts this little box up in the right-hand corner, and as I hover over an icon, it tells me what that icon is doing. If I hover over the outline of the while loop, it gives me access to the help system. And if you want to know everything you want to know about a while loop, click on Detailed Help, and it goes through the details that I'm about to preview. So I recommend using context help during these first 3 or 4 classes, just to kind of as a reminder. Okay, the while loop is characterized by this orange dot. And this is called, if you hover over it, it's called a loop condition. And what the word problem or the word statement is for this while loop is repeat the activity inside this rectangle until the loop condition goes true. All right, so right now, if we were to do something with this, we'd know it's in the false condition. I'm going to hover over it, the nipple on the left-hand side of the loop condition, right-click, and create a control. And you can see it creates a stop button for me. Everybody get your stop button? Anybody not get a stop button? Now, one of the neat things about LabVIEW is if I make a mistake, I can do a Control-Z and it undoes the last thing I did. So if you make a misstep, just do a Control-Z and do it again. So I'm going to right-click and create a control. This little eye over here, first of all, it's blue, And I means it's an integer. And if I hover over it, it tells me it's loop iteration. So this will increment every time this loop operates or loop does its thing. I'm going to hover over the nipple, right click, and create an indicator. We get, it's kind of purple color because it's an integer, and we'll see that show up in a second. Okay, now, and I want you guys to do this for a homework. I'm going to move this up, these two icons up. Anytime you'd use a while loop, make sure you have a delay time, a wait time inside. I hover my mouse in the center, right click, go to the timing palette, pick the wristwatch on the top row, left click, position, left click. Now you can see, as I hover over it, my context help says on the left side, milliseconds to wait. If I hover over the left side nipple, right click, create a constant, I'm going to type in 50. Okay, now my word statement is connect the joystick control to the motor, wait 50 milliseconds, and do it again. And by the way, increment the counter along the way.
Sir, can you do it like all over again? How you got the numeric thingy, like the watch icon on there?
Yep. So I'm going to do a Control-Z to back up. I position my cursor in the center, right click. I want to go to the timing palette. So timing is this one, center column, fourth row down. I can peg it, or I can just pick out my wristwatch, click it once, place it in the center, click a second time, and there it is. Did you get it?
Yes.
All right. Now hover over the left-hand side, right click, and create a constant, and type in 50. Does anybody know how long 50 milliseconds is? How many
Is that about the length of a blink of an eye?
Probably. That's something I don't know. What I do know is that if I go through this loop 20 times, it'll be a 1 second completion. So it's 1/20th of a second. Everybody buy that? So it's 50 thousandths of a second. Okay, so let's see if our program works. I'm going to go to the front panel. I'm going to push the run, click on the run button. I can see my indicator for the loops is just running wild. And sure enough, my joystick controls the motor. If I push all the way forward, I go forward. If I push back down, I go reverse. Anybody impressed? Jonathan, you got to be impressed.
Yay.
I like that. Okay, now let's go back. Now here's some advanced information that's going to be very valuable to you as we get into the physical robot. Now the physical robot is not going to have the front panel, so it won't be able to see these indicators like we do now. What we will see is the icons in the program, and so while it's running, all right, I'm still running, which is indicated by the running icon not being white up here, the run arrow. If I move my cursor over a signal line, it gives me that little P looking character. If I left click, it puts a probe that tells me what the value of that signal is at the current time. If I put a probe on the indicator connection, if I put a probe on my constant, so now I'm looking at 50 milliseconds on probe 3. I'm looking at the loop counter, integers up to almost 2,000 loops on probe 2. and my joystick value is point less than 1, less than a half. And as I move the controls and those values change, I literally am seeing the values inside the program. Now, that may not sound like a big deal now, but when you got a program that's not running and you got a robot sitting there looking at you, you're going to be glad to know how to do a probe. And we'll do that more as we get into the physical robot. Any questions about what we've done?
Sorry, could you, we got behind for a sec there. Can you tell us how to do the probe again?
Yep. All right. My program is running, right? By virtue of the fact that my white arrow is dark, it's running. I can tell the loop is so everything is working normally. If I click on the block diagram, program's still running. If I put my white hand on a signal line and click, it creates a probe for me. So there's my joystick value. I'm going to look at the loop value, the loop counter, and I'm going to look at the constant, which is the wait time on the wristwatch.
We got to click on each signal individually that we want to look at.
Yep. Now you don't have to do them all. You may just want to look at one, but the point is we are literally looking inside the program, and we can sit here and do other things on it, and it keeps it on the top of the screen. Fair enough?
Okay.
Now, let's get sexy here, guys. Watch this. I'm going to look at let me just show you. If I go into my settings for my window settings, and I look at my system, and I come down here and look at About, I can see I have a 2 gigahertz processor. It's dual core and 16 gigabytes of RAM. Okay, so that's just what it is. And this is a 2-year-old computer, so you guys may have a fancier one even than that. Now, what I want to point out is if I go to, and watch my screen while I do this, I'm going to do Control-Alt-Delete and open the Task Manager. All right, and I'm going to highlight the LabVIEW process, which is running, and right now it's taking up 1.5% of my processor bandwidth. Everybody following me so far?
Mm-hmm.
Now, if I move this around, if I activate, I'm engaging more often with this program, it bumps it up to maybe 6%, 8%, 9%. I'm going to stop my program. I'm going to change my wait time. I'm going to get rid of these probes. I'm going to change my wait time to a second, which is 1,000 milliseconds. All right. Now I'm going to run. Now watch, and this is something I want you to do on your own once you get offline. You can literally see a delay between the time I move and the time the display responds. But you notice there's not much difference between the bandwidth that I'm taking up compared to what's being the activity that's going on. So the point is, when you're talking about a human interface device, you don't want it to be too slow, but you don't want it to be too fast either, because it'll take up more bandwidth than is necessary. So this red button is the abort button. Most of the time when we're using robots, we want to use the stop or the finish, but for now on these simple, we can just abort. Watch what happens when I put in 0 delay. What that means is it's just going to continually run through this loop. There's going to be no delay whatsoever. Now when I run it, watch what happens to my bandwidth. I'm taking up 25% of a 2 gigahertz processor, and all I'm doing is connecting one joystick to one motor in a simulator. This would not be, I could not get any video out of my robot if that's what was going on. So the point I'm trying to make, and hopefully you'll get the point if you do this on your own, for manual controls, I want a relatively slow update rate. And so that's why I usually do a 55, anything between 50 and 70 as far as the delay time between running a loop. When we get into robot controls and logic calculations, I reduce that down, and checking sensors, I'll reduce that down to 10 to 20 milliseconds, but never, never, never do I want to have a 0, or worse, do I want to forget to put a wait stage in there, because it sucks my processor bandwidth down terribly. In the old days, it could literally.
So if you don't put a wait state in there, it just automatically assigns 0.
Yeah, I mean, this only does what I tell it to do, and right now I'm not telling it to wait at all. And in the old days, this would lock up a Windows computer, but because I have multi-core, I can bail out of it. But when I have a single processor, that processor is doing nothing but connecting these two icons. Make sense?
Yeah, I was going to ask, what if you have a kind of loop where it's going to stop after a few iterations? Maybe you while loop until you roll a dice
Okay.
and it's equal
So
to
you're
6?
looking ahead. You're looking ahead, but that's a good question. Let me show you what we're going to do. So right now I'm stopped. I'm going to right click. What happens if I say, well, once I reach 200 loops, I want to stop? Well, this signal, and that's what I want you to do, is go through and use context help and examine each one of the icons in the structures palette, in the numeric palette, in the comparison palette, the Boolean palette, and timing palette. Now, to answer your question, and this is what we'll be doing next week, is that if it's an if-then statement, right? And so I can use, there's multiple ways to get there, but the easiest way is with a comparison. So if I say I want to stop at 500, so I connect this up here. I do a right click and say create a constant with 500. And then I take off this control and I connect this. So now, if it doesn't equal 500, it'll be negative. But as soon as it gets to 500, it's going to stop my loop. So let's see if it works. Now, another thing is that just a point of condition, when we start a new loop, it resets everything to default. And we'll talk about how I can do that under my own control. And you guys let me do it. I ran it without a wait loop. So, note to self, never do that. So that was a trick. You were trying to trick me into doing this. And so let's just do 10 milliseconds and see what happens. Does that answer your question?
Yeah, I think so.
That was a very perceptive question, and I can tell you're going to be the guy we're all trying to keep up with, but you're going to love what we do next week. Any other questions? We're going to be doing a lot more than just this. So what we've done is simulate a joystick and a motor and what I'm going to send you guys is a PDF copy of these slides, and then a copy of what we're going to do next week for those of you that want to look ahead or work ahead. And that's not the one. And I'll show you what it looks like. This is where it starts to get fun. So I'll just send you a copy of the slides we're going to do, and you're welcome to start working on them. It's not all spelled out quite as nicely, but it is what we will do next week, and I'll walk through every one of them. But it looks like this. So you're going to be doing these constructions. I'm sending a copy of both the front panel and the block diagram, and if you can get it put together and figure out how it works, good. But other than that, we will do it all next week. Any other?
Sir, I have 2 questions.
Sure.
One, can we do everything you're doing even if we don't have a joystick? And 2, where are you sending the PDF files through?
Well, I was going to send them to anybody I have an email for, and if I only have the coach's address, that's who I'll send it to. Do I have your address?
No, but I can put it in the chat.
There you go. So I'm going to send this to anybody that's registered, and I have their email. If you're not comfortable handing out your email address, then make sure your coach forwards the information to you. It works for me either way.
Those of you that are on my team, we can do it either way. You can type your email into the chat box, or you can just send me a note and I'll give you a copy. Jim, I have a question for you.
Okay.
I've got a loose wire, apparently. How do you get rid of loose wires?
Control B.
Okay. All right, thank you.
Good question. Usually I have a bunch of them floating around, and you'll see them when we start doing the simulator. Other questions? Now, once we're through with this, we want to save it. So we come up to File. Again, we want to have stopped the program from running. Go to File, Save As, and you want everything to go into LabVIEW data. So under LabVIEW data, I want to call this JoySim. Now when I close it, I want to get rid of my context help. When I close it, it'll bring back the splash screen, and now I can find JoySim from under my LabVIEW data. And it's, again, this is where the VI I was talking about. VI stands for virtual instrument, which is a legacy. And so all this other stuff that I'm doing, these will be the robot projects that we'll get into in the 3rd class. So now I can go back and open that up if I want to relive or make changes to it. Okay, any other questions?
Sir, I got a question.
Okay.
What's the difference between putting a timer at 0 and not having a timer at all?
Nothing.
Oh, okay, got it.
And you don't want to do that. And you guys tricked me into doing it, and so I'm the best bad example you can find. And the reason it went to 500 in a blink of an eye because it was using 2 gigahertz loop speed.
You know, I'm very glad you mentioned that, because that's a really serious thing. I'm surprised that they don't put a timer in there by default.
Well, no. Okay, now that's a different subject. The whole menu in this WPI library that we're going to be looking at, this is, if you kind of come into this if you come into the timing, there's a bunch of different time delays that are, I mean, the answer to your question is they give us enough rope to hang ourselves. So that's why we're learning LabVIEW. But there are a bunch of different elements that control time and give us the ability to delay something. And what I was getting at is sometimes, especially coming out of the WPI library, sometimes they don't work as well as you think they should, or I think they should. And so that's why I try to stay as simple as I can. And when we get into the robot, you'll see that not only you don't want a long delay because it locks in that loop and it doesn't release the thread even to a multi-core processor. And so we'll see evidence of that. And those of you that have done programming, and this we'll talk about next week, there's an element that's built into every program that's ever been commercially produced called the Watchdog Timer. And the purpose of a Watchdog Timer is to make sure the computer, the processor, doesn't get lost and does something that's not safe. And in FRC robotics, that ends up being in the actuator controls. If you don't update the drive controls, the motor drive controls, every 100 milliseconds, they stop because of the Watchdog Timer. So if you've got a program that locks up for a second, your robot's going to stop about the third second you're on the field. And so anyway, that's fun stuff to look forward to. Any other questions?
I have less of a question, but more of a comment. Which is, I think there could also be a situation where you would want zero delay. For example, if you wanted to create 20 instances of a class as fast as possible. I'm not sure what you use that for exactly, but that's reasonable, I guess. I don't know.
Well, see, there's nothing that I do that'll be as fast as a computer. So if it has anything that has to do with a human, no, I don't want to ever have no delay in there.
Yeah,
so,
excluding like HID.
Yeah.
Yeah.
Human interface device. So yeah, now if we were instantiating, see again, the stuff you're talking about is G code level. It's not in graphical language level. So there's levels there that you don't want to get into, and because you stumble over stuff that they're not telling you about. Just for what it's worth. Okay.
Fair.
Any other questions? Anybody else? If anybody had trouble with any of this, feel free to hang around and let's iron out your issue. Is anybody having problems they can't iron out? Now's the time to speak up.
Tate, you had a question that you typed in the chat box. Would you like me to read it out? Because Tate was saying that apparently his microphone isn't working. So his question was, he says, I missed the grid setup. Could you repeat that, please? And when I asked him, what do you mean by the grid setup? He said the first customization.
Okay, fair enough. Now I apologize for not keeping track of the chat. What it boils down to is you can do this any way you want, but it's for a class setting, it's good to both of us be on the same page. So once I launch blank VI, it gives me a front panel and a block diagram. If I right click and pin, the little push pin is available to me in this top left hand corner. If I click on it, it pins the menu and then allows me to customize and change visible palettes. So if I select all of them, which is the default setting when you first install the tool, it looks like this. And we're not going to be using these elements down here. So what I suggest is you go back and customize, change visible palettes, deselect all, and just check modern, and then click OK. And it'll look like mine. So that's on the front panel. Same thing on the block diagram. Customize, change visible, select all, It looks like that. If I deselect, I only want to show programming, and then the last three on the bottom of the scroll, WPI Robotics, PID, and FIRST. How's that work? Good. Anybody else? Guys, I appreciate the feedback. It helps the dialogue and helps me understand when I'm getting things across. And we'll talk to everyone on Thursday night, same time, same station.
Fantastic, Jim. Thank you for doing this.
Good. See everybody then.
All right. Have a good day.
So long.
So,
Thank
sir, just to clarify, we can do this without a joystick, right?
Correct. Yeah, everything we're doing. So, yeah, in fact, we're going to simulate a joystick using those front panel controls next class. And you will be able to operate the simulator without a joystick. I saw you coming. I saw you coming. Fair enough?
Thank you, sir.
You're welcome.
Yes.
Thank you.
You're welcome.